Well, then let's go back then to this one we did a moment ago. I can do a complete ionic equation from this. Since we've done these before, can you tell me what it is is there anything in particular that's confusing you that I can help you with? All right. So let's back up just a little bit and discuss some previous stuff, okay? When we were first building formulas, in fact, a moment ago when we built these formulas, we put these together using ionic charges, didn't we? Right? Yeah. When we put copper together with phosphate, we had to know the charge on the copper, the charge on the phosphate. We figured out a ratio that would give us a zero charge overall. And that's how we learned to put the coefficients here and then finally the subscripts here. When you're writing an ionic equation, you're simply undoing all of this. So you're going from, instead of going from this to this, when you're writing an ionic equation, you're going from this to this. That's all you're doing. Okay? All right. So, but when you're writing an ionic equation, you don't break up things that are solids. The process is the same as we used here, but we're not going to break this compound up right here on the end because it's a solid. The only compounds you break up in an ionic equation, the only compounds you break up in an ionic equation are the acids, or the ionic compounds. The only compounds you break up in an ionic equation are the acids or the ionic compounds that are also aqueous. Acids or ionic compounds that are also aqueous. So if you've done everything you're supposed to do to properly predict the physical states, then you just got to go through and find out, is it ionic? Is it aqueous? If so, you're going to break it up. Okay? So, let's identify any of these compounds here that are both either acid or ionic. That's number one. And two, aqueous. Okay? Let's look at the first compound. Is it acid or ionic? How would you know if it's acid? Well, not if it's acid. How would you know if a compound is acidic? Got to be a hydrogen in the front. There isn't one, is there? No. How would you know if it's ionic? The polyatomic ion in this case tells you this is an ionic compound. So this one's ionic and it's aqueous. We're going to break this one up. Okay? All right, what about this next compound? Is it acid or ionic? Or is it something else? How do you know it's ionic? Metal bonded with a nonmetal. This is ionic. Okay? Is it aqueous? Yeah, it is. It's aqueous. So we're going to break this one up. How about this one? Is this ionic or something else? Or is it acid ionic or something else? Okay, you don't think it's ionic? It's a metal bonded with a nonmetal. Okay, it's ionic. Is it aqueous? We're going to break it up. All right, is this acid or ionic or is it something else? It's got a polyatomic ion. It's ionic. Is it aqueous? So we're not going to break that one up. Okay? All right. If we're going to break them up, we're simply going to undo this the same way we undid this a minute ago. It's going backwards in what we're doing right here, where we're taking these two things and putting them together to make that. That's all we're doing. So this is a sodium that we're going to break apart from a phosphate. Since this is an ionic compound, I need to make these ions, since I've broken them up, since they were ionic compounds, I'm going to make them into ions. So what charges do I put on these two things? Where do you find the charge for sodium?
On the oxidation.
The periodic table with oxidation numbers. What charge then do I put on that? Use yours and answer the question. What charge do I put on sodium? 1 plus. It's right there on the common ions list. Hello? Okay. Hello? I think I accidentally hit a button. Okay. 1 plus. What's the charge on the phosphate? Where do you find the phosphate?
Is that the same from earlier?
3 negative. Where do you find that? Common ions list. We wrote it down a moment ago. Okay, but you find it on the common ions list. Okay? So we got a 3 negative on the phosphate. Now we need to know how many of these do we have. How many sodiums do I have? How many do I have in this formula right here? How many do I have? I have 2 of the whole compound. How many sodiums do I have? 6 of them. Okay? If the whole thing is aqueous, then this ion is aqueous. How many phosphates do I have? How many total phosphates do I have? No, I have 8 oxygens, but I have 2 phosphates. Okay, since the whole compound is aqueous, this ion is aqueous. Okay? Alright, this one's going to break up. Can you break this one up then? Please break that up. Please, everybody, break that one up. Break it up.
Could you move like the 3 on the side to make it? Oh wait, is that 3 actually there?
I have 3 of these formula units.
Subscript, or would you keep it like that?
No. I have 6 sodiums here because I had 3 in the formula times 2. That's 6 of those. How many coppers do I have? 3. We'll write them out. Yeah.
Are we replacing what you just wrote down with the NA and 2 NA3 EO? Are we replacing that?
I'm not replacing anything. I'm breaking these apart.
Oh, so it's just like equation by itself. I thought you was like trying to put that right where you can.
No, I'm trying to write a complete ionic equation. That was the question I was asked about.
So why do we have a plus on the
Because I broke them up.
No, I'm talking about the next. Go over right
Because I'm ready to put this in here now.
Oh,
That's this plus sign dropped down here.
that's all I was asking.
Oh.
I thought you just told me that 2 and 3
They can't in the formula here. They have. Well, I'm sorry, you didn't give me a complete question, so I didn't know how to answer you. How many coppers do you have? I mean, how many chlorines do you have?
5
Okay. What charge do we put on these? Yes, please. What charge do we put on these?
What charge do you
All right. Okay, class, can I get everybody to be quiet? Can I get everybody to be quiet and focus their eyes and ears up here?
I'm looking at you.
All right, I can see you are. Thank you. How many eyes do you have? How many ears do you have? How many mouths do you have? You should be listening and looking 4 times more than you're talking. At least. Okay?
You supposed to look and listen twice as much as you talk. You got one mouth.
Okay? Alright. That's bogus math, but nevertheless. Alright.
Excuse me.
Shh. What charge do we put on this copper? How did you get 2 plus? We did it earlier, didn't we? We figured it out down here. Can you not figure it out again? The chlorine has a 1 negative, the copper has a 2 plus. What physical state do I assign to these ions? They're both aqueous here. They're going to both be aqueous down here. You are trying. Okay? And those of you who are trying, kudos. Those of you who are not trying, who are playing and talking and doing other things, you get the grade you deserve. What do I do to this?
You take it down and see.
I'm going to break it up. Okay? Okay, 6 sodiums, 6 chlorines. What charge do I put on those? Positive 1, negative 1.
They cancel each other out.
That's where that's why I got them there. Yes, but you would look that up where? How would you know?
On the opposite section. Can you zoom in a little bit? That'll be smart.
What physical state do I put on these? If the compound is aqueous, the ions are aqueous. I need a plus sign between them. What do I do to this?
Break it down.
No, it's a solid. You don't. Shh, shh, shh. What compounds do I break up? Ionic or acid and aqueous. 2 parts. Ionic and aqueous. Ionic and acidic and aqueous. It's got to be both. Can't be one. It's got to be both. Ionic or acidic is one. Aqueous is the other. If it's not both, you don't break it up.
How do you know if it's
Hydrogen's on the front. That's how you find out if it's acidic, if the hydrogen on the front. So this one we're going to leave alone because we can't break it up. All right. There is a complete ionic equation.